Apache Hudi is a transactional lakehouse project that brings database and data warehouse capabilities into the data lake. Hudi originated in Uber in 2016 when Uber was going through a hyper growth mode, migrating from warehouse style architecture to a data lake based architecture. Back then, we used to bulk ingest the trips change logs into the raw layer using Parquet formatted files. And this used to happen every 8 hours once or so, whereas the actual change would be just 500 GB, but we kept bulk ingesting 120 terabytes. With Hudi, we are able to see that the absurds now took less than 10 minutes for absorbing those 500 GB worth of changes. And the downstream tables can happily query just the changes that happen from the raw table and build data. And the end-to-end data freshness dropped to 1 hour from 24 hours. So as you can see, this propelled a lot of use cases inside Uber, and Hudi started to grow rapidly. So this is Hudi in action. Hudi is massively proven in the industry. Across the board, you will see multiple examples where these companies are able to leverage Hudi in production and be able to realize the entire analytics latency going down from daily to minute level and to capturing different sets of CDC use cases and other types of use cases. Just to name a few, Uber and TikTok are able to see these latencies go down across huge tables and petabytes and exabytes of data.
So our goal is to build the first transactional database for the lake with polyglot persistence, which raising the level of abstraction even higher for Hudi data lakes. Let's look at the opportunities that we have right now. So first things first, you have data, then you want to be able to query that data. And the way the query engines evolved, most engines preferred a separate integration, leading to Hudi maintaining its own connectors for Spark, Presto, and Trino. However, this opens up opportunity to leverage Hudi's indexing capabilities during query planning and execution. And more importantly, Hudi can leverage recent innovations in query acceleration through reusable components as provided by the Velox project from Meta. Today, we have advanced engines like Apache Spark and Flink that have mature extensible SQL support, and we can support a generalized relational model for Hudi tables, where just like databases, you don't really have to create a primary key. You just go ahead and create a table. We need to embrace a hybrid architecture where we employ server components for table metadata while remaining serverless for the data plane. We need to support all the major image, video, and ML and formats that support ML AI workloads with the same depth of capabilities around indexing and mutating or capturing changes. And last but not the least, self-management. That's the edifice on which Hudi rests. Even 0.x line, we have compaction, clustering, cleaning services running in the background. We want to build on top of that and provide things such as snapshot lifecycle management, diagnostic reporters, cross-region logical replication, record level time to live management, just to name a few.